Hello there, how are you doing? You're welcome back to Biology Lectures with Akari Ladimich Philip. So move on to sex determination, which is another topic on the Gcse curriculum. That's basically topic 6. So section 6 in the curriculum. So sex determination refers to who determines the sex of a child. Is it the father or the mother? Is it going to be a boy or a girl? Now there has been a lot of let's say preferences to this. Okay, some culture prefer the female child to the male child, and some prefer the male child to the female child. But what we'll be doing in this lecture is to see who actually has the or who decides that. So let me say at this point, nobody really decides the gender of a child. What I mean by that is, okay, it's not the father that says, okay, I want the child to be male, I want the child to be female. Rather, it is the fact that the chromosome that determines the gender of the child is with one of them. So generally speaking, you should remember the fact that each cells in the human's body, has 23 pairs of chromosomes, or you say 46 chromosomes. I did that when I was talking about overview of genome. You may want to check the video on that overview on genome. Now, if that be the case, but we have another set of cells which are called reproductive cells, which has just 23 chromosomes, not pairs. Now, I'm going somewhere with this. Now, you want to know that I think I want to draw something here. Now, you have 46 chromosomes. So from first pair, so let's say we have, I think I should have, good, this is good enough to demonstrate that. So we have from 1 till 22, all of these are called autosomes, all right? And this one is called sex chromosome. So if it's a male, it's going to be X and Y like you're seeing it here. Then from 1 to 22 is also autosomes in the female. If it is a female like you're seeing, it's going to be X and X. This is very important. So female are basically homozygous, or homo because they have the chromosomes are identical, same, while the female the males are heterozygous. Now, because this is a normal body cell, this is not reproductive cell, this is just a normal body cell. Why do I say that? Because it's in pairs. So if you count this is pair 1, pair 2, till this pair 44, pair 22, then that's going to be pair 23. So the 23rd chromosome, pair of chromosomes is always the sex chromosome. Now, of course, you can also count it singly, say 1, 2, 1, 2, then this would be 43, 44, all right, 45, 46. So this is a normal body cell in the organism. Just normal body cell, as it were, in the human, just any cell of the body, which is not reproductive cell. And this sort of cell is called diploid cells. Okay, now coming back here. So it says here in the females, the sex chromosomes are X and X. The sex chromosome in the males are what? X and Y. Why this is very important is because this is the real thing that determines the gender of a child. Now let's get right into it. Now in X cell only has 23 chromosomes, not pair. And the sperm cell only has 23 chromosomes, not pair. Why? Because they divided by meiosis. Meiosis is basically a division whereby the daughter cells will have half of what was in the parent cell. So if a cell had 46 chromosomes and divided by meiosis, I beg your pardon, it's going to happen twice. So at the end of the day, the 4 daughter cells formed, we have 23 chromosomes each. So that's going to be half, not 46 like the parent had. Now, what that means is this. So in the case of humans, now, so the last chromosome in a sperm cell, so that means I'm talking about, if I say, it's not in pairs, now it's just singly, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. This last one, if it's a male, it can be X or Y. I said or, because here the male has X or Y, or X and Y. So imagine if you divide this into 2, that means it's going to be 23. So that means a part of the 23 we have X, another 23 we have Y. That's why you see I said here that the last chromosome can be X or Y. So, but if it's a female, because they are homozygous, both sex chromosomes are both X, so the last one's going to be X always for the female. For that reason, it is the male that determines. Now, it is the factor, the chromosome that determines the gender of a child, the sex of the child, is in the male's body. Now, when you hear me say, I said the factor that determines, I didn't say the man or the male determines, because he doesn't know, he doesn't decide what sperm carries what. So that means in a man's body, so let's say we have millions of sperm cells, if not billions. So some sperm cells are having Y chromosomes at their last 23rd chromosome, and some are having X chromosome at their last 23rd chromosome. You must know this. So in a man's body, the sperm cells have various chromosomes. I mean, their last chromosome, some are having Y, some are having X. This is the real thing that determines that. So if the X cell is fertilized by a sperm carrying Y chromosome, that means XY, that person, the expected child will be what? A male child. Then on the other hand, if the sperm cell that fertilizes the egg is carrying X and fertilizes the X, that would be a female child, which is XX. Please don't forget this part. It's very important to know that the factor is in the man's body based on if the 23rd chromosome is having Y, or if the last 23rd chromosome is having X. That determines the gender of the child. So if you look at this here, so you see the sperm cell here is carrying X. Come out with the X, that's going to be a female child. Now this XX is talking about 23 chromosomes, the 23rd chromosome from the female, 23rd chromosome from the male, 23rd chromosome from the male, 23rd chromosome from the female. All right, so that brings XY. We did not put into account the other set of chromosomes, the autosomes. I mean, we don't do that because of simplicity.